Right, hi guys. Let's look at question, where are we? Yes, 39 to 41. I'm going to try and do them all together, as in one after each other. Oops, sorry, it's not that one. It is that one over there. Let's see. Question 39 to 41. So let's look at this and and work through this. Okay, great stuff. So here we have it says that a company makes two products using the same type of material and skilled workers. This is my calculator. Yes, the following information is available. So for product A, this is the number of units. Product B, number of units. Here is the material per unit. And here is the material per unit. And here we have the labor per unit. And here we have the labor per unit. So it says the fixed costs relating to materials. So fixed costs relating to materials here amount to 100,000. So literally, we have spent $100,000 here, and it says, well, the cost driver, of course, here is the volume of materials purchased. So I can find that if you did 1,000 units here, and then you have 10. If you spend 10, given that we're using the same type of material, you could argue that, well, it's the same type of material, so you're spending more here. I mean, you could even look at it from here at a ratio of 1 to 2. You could sort of say, well, for every unit you're using, say, 1 kilo. You can imagine that, you don't have to, but you can imagine that 1 unit, if you like, was $10. So you're using 1 unit here, you're using 2 units here. You could look at it that way if you wanted to look at it in amount. Or you could just look at it in currency. The same thing. Direct correlation between material amount and amount you're spending on it. So I think the safest thing is to just calculate all the material, how much you spent on all the material, if you like. So here you would have spent, therefore, 10,000, because 1,000 times 10 is 10,000, compared to you would have spent here 20 times 2 is 40, so 40,000. So you'd have spent, if you like, £10,000 on material on product A and £40,000 on product B. That's sort of the way to look at that. And now you know that you literally have to split this 100,000 on the ratio of this 10,000 to 40,000, if you like. So that's kind of a 1 to 4 ratio, if you like. So I mean, I could just do that right now, right? I could sort of say, well, that means that you could find the overhead absorption rate. I mean, this is if you like, an objective question, but as you get better, you can sort of think that, right, okay, well, I'm going to split this 100,000 between the ratio 1 to 4, right? And so you know that's really 5 ultimately, isn't it, as a total? So you could say 100,000 divided by 5, that gives you 20,000, of course, right? And then, if you like, so you know that you're spending 20,000 here, and you know you're spending 80,000 here. So I can create a little table here and go material handling, if you like. The fixed cost relates to material handling. For A, it's 20,000, and for B, it's 80,000. I suppose that's sort of the speed you get to when you start working on this, as opposed to going all the way to calculate an overhead absorption rate, which you can, which would be, if you like, 100,000 divided by 40,000. But in of itself, that's slightly, divided by 50,000. That's slightly tricky because this is in currency. You would have to assume units, which you could, but you don't need to. We just need to split this cost in that ratio. That's the thinking. And then we do exactly the same thing here. So when we look at labor per unit, I could almost argue again that I imagine I was spending, and it's just the imagination, isn't it? Imagine I spent £5 an hour. I've technically spent 1 hour here, and then I technically spent 4 hours here, because it's the same, you're paying the same amount per hour. So you could think of it that way, and therefore then think, okay, well, how much time have I spent on this? So that's 1 hour times, you could use the currency, you could use 5. Same thing. Let's pretend it was 1 hour. So you spent 1 hour times, you spent 1,000 hours, which would be the 1 hour times 1,000. They haven't told us it's an hour. I'm just making it up, imagining. I'll do it both ways so you can see where I'm going. So imagine it was an hour. That's 1 times 1,000. That's 1,000 hours. And here you have 4 times 2,000, and that's 8,000 hours. So you can see the ratio is 1 to 8. Let's see, I'd use the 5. I would have said 5 times 5,000. 5 times 1,000, which is 5,000. I'd have said 20 times 2,000, which is 40,000. That is the exact same ratio. 5,000 to 40,000 is the same ratio. 1,000 to 8,000 is the ratio 1 to 8, in effect. So, like I say, it's less about finding the overhead absorption rate for fact. It's more about, I understand that I need to split this overhead here in the ratio of driver quantity, because they tell us. So therefore, if I'm splitting this 180,000 in the ratio 1 to 8, that's sort of, this is at these together you get 9, so that's when I say 1 over 9 times 8, 180,000. So that's 20,000 again here, and that's 160,000 here, right? So I'll just put here 160,000, and I have here 20,000. So they wish me to focus on B, and so therefore for B, that would be, this is the total overhead relating to B, so that's 80,000 plus 160,000, and that's 240,000. And the question says that you made 2,000 units. So 240 divided by 2,000 brings us to the comfortable figure of $120, right? And that's how you go about that. Good. Let's look at the next one. Okay, great. So what we have here is, it says a company is changing its costing system from traditional absorption costing based on labor activity to ABC. So they're currently using a labor system based on, driven on hours and that sort of thing. So this is the overhead itself, what we're trying to separate out and work with. And this is related to taking material delivery. So this is sort of the switch. So they're going from using hours. So currently here, these are the number of hours that drive this thing. So, I mean, I'll just work that out on a basis of, if I know the total number of hours, you know, don't get harangued or waylaid by this thing here. This is direct labor costs. I'm interested in dealing with overheads. This is all about overheads. So what I can really do is I can find what the overhead absorption rate is per hour, right? So ultimately that's, what's the word? Yes, divided by 45,000 hours. Again, really, let me just even do this just because, divided by 45,000 hours. So that's, 156,000 divided by 45,000 hours. And that's £3.46 per hour. And then what you then need to do, and then I'll sort of show you why you don't need to go all this way, but you could do it the way we would if you're doing an exam. You would do it like this. You say, okay, well, that's what it is per hour. You can then actually find the number of hours that take place here. It tells us that each unit takes the same number of direct hours. So technically, if you have, this is 1,000 units, 2,000 units, 3,000, so in total you have 6,000 units. So you could find the number of hours used to make each unit. You could say, well, therefore, you have 45,000 divided by 6,000 units, and that comes to 7.5 hours per unit. Well, then you could then say, well, therefore, X takes, if you like, the total number of, the total overhead allocated here will be, well, the total number of hours for X, if you like, is 7.5 hours per unit. So that's 7,500 hours. That's 15,000 hours. And therefore, that is 22,500 hours. And so I know the number of hours, and then I could go ahead and multiply each of these by 3.46 to sort of get the total amount of. But just by looking at this, I hope you can see, right, that all I'm literally doing, because there's a direct correlation between the number of hours and volume, is literally spreading this 156 cost based on this ratio. They're exactly the same ratios of 1 to 2 to 3. However you look at it. So really, in an exam, the skill you're trying to acquire is, well, I just need to split this overhead based on the ratio of overhead hours, which are directly related to number of units. In this case, because it tells you that each product takes the same. If it took a different number of hours, then it would be really important to calculate this. But you don't, because they all take the same amount of time. So, but you can still go ahead, not a problem. It's just making sure you're keeping it tight. So if I was just simply doing that on this sort of system, I would simply, literally, if I was just going to use the ratio to look at the spread of this overhead using absorption costing, I would simply say for A, let me just see if I can clean that out, give myself a clean screen. I would literally just say for 1/6, because this is 6,000, isn't it, in total? 1,000 plus 2,000 plus 3,000 is 6,000. So 1 over 6 times 156,000 is the case for x. 2 over 6 times 156,000 is for y. And 3 over 6 times 156,000 is for z. So if I do that very quickly, I have 1 divided by 6 is equal to times 156,000. So I have here 26,000. I have here 52,000, of course, and I have here 78,000. Okay, right, and that's how I would have spread this overhead based on labor hours. Now they tell us we can actually use, we should actually, for activity-based costing, we should actually do some material handling, looking at that relationship. So I need 1,000 units every time the delivery arrives. 200 will arrive at a time. So in effect, I will need 5 deliveries here. I have 2,000 deliveries. Every time each delivery arrives, I have 400. So I will have 5 deliveries here. And here I will have, of course, 3 deliveries, because if it's coming in batches of 1,000. So in total, I have 5, 5, and 3. So in effect, I'm splitting this cost based on the number of deliveries. So again, I can just see straight away that here I could sort of, change a gear and say, well, the total is 13. So that means this is in the ratio of 5 over 13 times 156,000. 5 over 13 times 156,000. 3 over 13 times 156,000. So I can calculate that. Let me go ahead. 5 divided by 13 is equal to this times 156,000. And here I have 60,000. I'll just write this. I'll just write that over here. 60,000. I'll have 60,000 here, and I'll have the difference, which is yes, it's 26 or 36,000 here. So the question is asking, moving from this system to this system, what happens to these overheads? Well, product X we can see increases, product Y we can see increases. So X goes from 26 to 60, Y goes from 52 to 60, but Z falls from 78 to 36. I would argue this is the neatest and fastest way to do it, as opposed to going to calculate the overhead absorption rates, which you can, but again, like I say, it's just trying to move quickly. Right, and finally, the last question in this batch of questions is question 41. So here again, this is a classic activity-based costing question, long-winded, so it's important to be very careful. Let's look at the information. We're talking, so literally to follow this through, you're talking about 100,000 units. You have 100 units in each batch. So in effect, the question here is, what you're trying to work out is, well, how many batches, if you like, am I working with here? So if you have 100 units in each batch, you can see that you have 1,000 batches here, don't you? And here you will have, yes, 100,000 divided by 50, and you will have 2,000 batches here. So do the division just to be sure. And then here, of course, you will have 50,000 divided by 25, and you have 2,000 batches here as well, because it tells you that in each batch you have 100 units. So in a total number of units of 100,000, you will have 1,000 batches, 2,000 batches, 2,000 batches here. So and that's what you have. We're interested in the machine setup, so we're told that you have machine setups per batch of 3 per batch. So in total, therefore, you will now have 3 times 10,000. So you will have 3,000 setups. Here you will have 4 times 2,000. You will have 8,000 setups, and here you will have 12,000 setups. So in total, you will have 3 plus 8 plus 12, 3,000 plus 8,000 plus, which is 23,000. So you will have 23,000 setups. So 23,000 setups drove a total cost of 150,000. So please follow that through to make sure you're comfortable with that, because the machine setups are per batch, and that's the number of batches you have. I'll just write here number of batches. So I need to find the total number of batches. I'll do exactly the same thing here. Purchase order per batch, so that's 2 times 1,000. So I have here 2,000. I have here 1 times 2,000 again. well, this was 2, sorry, this was 2 times 1,000. This is 1 times 2,000. And here I have 1 times 2,000 again. Interesting. I feel like I didn't notice that the first, oh, sorry, I've missed that. Yeah, so that's the number of batches, isn't it? Yes. So here I have 2 times, I just want to make sure I get it right. 2 times 1,000, yes. 1 times 2,000, and 1 times 2,000 as well. Okay, great. So you now have a total of 6,000. Right, good. And then what we now have, of course, that means that 6,000 batches are driving this cost here of 70,000. So what we now have here is it tells us that you have processing time of 2 minutes per unit. So you have here a total of, well, here you have your unit. So you have a total processing time, therefore, of 2 times 100,000 in minutes. And here you have 3 times 100,000 in minutes. And here you have 3 times 50,000 in minutes, if you like. And so I think what I might do is just convert these to hours, just because and I'll divide all this by 60, and I'll divide all this by 60. I'll just have really massive numbers. So I'm just going to do that first. So 2 times 100,000 times 100,000 divided by 60 is 3,333 hours. Right, and I'll do the same thing here. 3 times 100,000 divided by 60. I get 5,000 hours. And I have here, actually it's interesting because I think this question just really wanted to know what is the budgeted, but I'll just finish this so you can see how we calculate this. So we don't even have to find the full thing, but this is important to just sort of work that out. 3 times 50,000. 3 times 50,000 divided by 60. So here we have 2,500. So I know here that I have a total of, I said 3 times 50,000 divided by 60 is 2,500 hours. So I have 2,500 hours. So I have a total of 2,500 hours plus 5,000 plus 3,333.3. I have a total of 10,833 hours driving processing. The question, so I've just done the total so you can see how you would have worked this out. But the question just wants us to focus on machine setup costs. So if I focus on machine setup costs, I'm just interested in this business here. So let me find what the cost is per machine setup. So that's 150,000 divided by 23,000. And that gives me 150,000 divided by 23,000. That gives me a figure of £6.52 per setup. Right, so let's look at product R. And product R, I have 4 setups, if you like, when I'm trying to work on a batch. So I have a batch of 50 units. So it says you need 4 setups. This is per setup. So for every batch of 50 units, every batch, one batch, has 50 units in it. So in order to in order to set the machine up, you need 4 setups, if you like, just to deal with a batch. You can see machine setups per batch. So £6.52 times 4 is the total cost of dealing with a batch. So £6.52 times 4 is equal to £26.08. So this is the total cost of dealing with one batch. And in one batch you have 50 units. So when they ask me what is the setup cost per unit, I need to say, well, £26.08 divided by 50 will give me the cost per unit divided by 50. And I arrive at the lucky number of 52p. So it's just about making sure that you actually understand what it is you're trying to do. Your units live in batches. You know what the total cost is for a batch, or that's what you're trying to do. You're trying to get to the total cost for a batch, given that you know the number of setups for a batch. So if you get that, then you can now divide by the number of units within the batch to know what the cost is per unit. And that's the answer there of 52p. Okay, great stuff. Yeah, slightly long-winded, but this was a way coming to the longer calculation numbers. So this is what we sort of expect to spend that kind of time working on that. Okay, great stuff.